source and test files. Okay, Maven will create project structure with source and test files. Okay. Now you will have a lot of Java files. Okay. You will have a lot of Java files. These are all Java files. Java files. .java files. In addition to that, you have pom.xml also. In addition to that, you have pom.xml. In pom.xml, what you will specify? You will specify the dependencies. You will specify the dependencies. Now, what are these dependencies? So these .java files are written by you. These .java files are written by you. But whenever you are writing these Java files, you need some third-party libraries for some functionalities. Say, for example, if you are developing this project using Spring, you need Spring-related libraries. If you are connecting to database, you need database-related libraries. Okay. If you are connecting to some other utility classes, you need Apache-related libraries. So you need different libraries. Okay. So those you define in dependency section of pom.xml. Okay. Now what pom.xml will do? So it will try to see these dependencies in the local repository. Yesterday I told you that. If it is not available, it will connect to the internet, go to the Maven repository and download those repositories and import in your project. Okay, fine. So once all these libraries and .java files are there, what Maven does? So Maven will compile the project, compile the files in the project, and then packages all these files into one jar file. All these files into one jar or one war file. Into one jar or one war file. Okay. Now this jar or war file will be generated. Now this jar or war file will be copied, and how it will be copied? You will have some pipeline like Jenkins and all that. Okay. So I'll show you the Jenkins also in our tool section. So you'll have a Jenkins pipeline that will take this jar or war file and copy that to server. So this jar or war file will be copied to the server. Will be copied to the server. Okay. So this is how the flow. Now in the dependency section, we have there is an option called, so in the dependencies, what we specify group ID, artifact ID, and version. So which version we need, which artifact ID we need, and all that. Apart from that, we also specify scope actually. Okay, the default scope is compile. The default scope is compile. So when we specify compile, so what will happen is the libraries that are specified in the scope compile will be used in the compilation of these Java files. Whenever these Java files are compiled, which are written by you, so these libraries that you specify in the dependency section will be useful for compilation. Okay. So will be useful for compilation. Next, it will be useful for testing. Testing means whatever you write in JUnit test case, right? It will be useful for testing and running. Running means, what do you mean by running? Now, once all these files are packaged into one jar file or one war file, that will be copied to the server. And how that is copied? We have pipelines, we have build tools, CI/CD tools like Jenkins. That we'll see later actually. Okay, Jenkins is separate one. So through Jenkins, we'll copy this to server. And what will happen is, now this jar file, now this jar file now will contain all the .java, all the .class files. That means .java is compiled to .class, right? So all .class files. And also the jars that are part of these dependencies, this third party. So the dependency jars. So this jar will contain all the .class files. .class files means this is a .java. When it compiles, they get converted to .class, right? So .class and dependency. Dependency jars means whatever you add dependency. Because when the scope is compiled, the dependency jars will be put into the jar file automatically. That means the single jar file contains all these class files and also these dependency jars. That is what scope compile. So that means these jars will be useful for running also. That means whenever this jar is getting executed, these jars also supports that. Okay, that is what scope compile. Now, the next one is scope provided. In scope provided, what will happen is, now the dependencies will be supporting, the third party jars will be supporting when the Java files are compiled and tested only during compilation and testing. Only during compilation and testing. Okay, but not during running. That means, but not during running. That means in the, so once this all these files are packaged into jar or war file. Okay, that means when Maven packages all these into all the class files. Why class files? Because .java when compiles, they gets converted to class files only, right? So when Maven packages all the class files, and these class files are written by you, that are project specific. Okay, it will not include the dependency jars into the, when Maven packages all the class files into jar file, it will not include the dependency libraries into the jar file where the scope is provided. Where the scope is provided. That means if those are not part of the jar file, and this jar file will be copied to the server, the jar file is copied to server, and the dependencies which are scope is provided are not included in this jar file. So that means these jars are not used in the execution of this. That means during the running. During the running, it is not used. When the jar is running, it is not used. But where it then how it runs? That means server will be having some libraries. So it will take those libraries. So for example, these provided scenario will be applicable when, for example, servlet APIs, which I told you, right? Servlet. So the servlet API can be part of provided. Why means a servlet API is already provided by Tomcat server or some other servers. You don't need to put this dependency in your jar file. Okay. So during the running of the Java program, during the running of the jar, it takes that jar from the Tomcat server. Okay. It need not take this from this dependency. But this is used only for your compilation. Whenever you compile the project at the time, this class should be required, because when you write the program, you will be using some packages related to servlet, like import org.http servlet request methods. All those classes and packages are part of this library. So during compilation, it will be useful, but during the running of the jar, it will take from the server related library. So that's why you can put scope as provided. Okay. That is what. Understood, right, everyone? Now runtime scope. So what do you mean by the dependency runtime scope? So in the runtime scope, what will happen is the dependencies specified in runtime scope will be used only for testing and running. Only for testing and running, but not required for compilation. But not required for compilation. So when we say testing means, when you run the JUnit test case, testing means when JUnit or Mockito test cases are executed or test code is executed, testing means when JUnit or Mockito testing means when JUnit or Mockito test code is executed. So these dependencies are used. So these dependencies are used. And running means when the jar or var file executes, gets executed in the server, these dependencies are used. But during the compilation, these are not required. See, for example, I'll tell you one scenario. Let me take this. Let me take this example. So this, I'll tell you one practical scenario for this. Okay. So I told you one program, right? See, I added a dependency related to MySQL in one of the test cases. Why? See, if you see, this dependency is nowhere used during compilation of the project. So this is used only when the program is connecting to the database. That means during the runtime or during the testing of the project. So this MySQL dependency is nowhere used during the compilation, because when I open the compilation of this project, when I open this project, you see, let me see this. Here, if I open this order DAO, I'm using this this class as part of MySQL library, but nowhere I'm importing the package of MySQL. These are all just java.sql. So this library or this dependency is used only during the runtime. It is not required in the compilation. That means even if I don't have this dependency, I can compile the project. I can compile. I can convert the Java file to .class file, but I cannot run the project. I cannot run the program. See, there are two steps, right? One is Java C compilation. Another, after compilation, there is another step, Java, that is running the program. So I can compile the project. I can compile the project. That means even if I remove this, I can compile the project, but I cannot run the project. Why? Means while running, it will load this class. It will load this class, and this class is part of this library. And this class is part of this library. And it will expect this library to be in the class path. Otherwise, it will not run the program. But during compilation, not an issue. This program gets compiled successfully. Because nowhere I'm using MySQL related packages. This is all just a Java SQL. Java SQL is part of your Java standard edition. But this class is part of MySQL package. So that's why even if I don't have this library, this program gets compiled, but I cannot run the program. So that's why I can put here this as scope as runtime. So when I put scope as runtime, you know what will happen? So this library will be used only during the testing and running only. So it will not be used during the compilation. Understood, everyone? So even if I don't have this library, the project gets compiled, but you cannot run the project. Why? Because if you see here, so while running, this will load this class, and this class is part of that library. So this is what runtime. Okay, this is an example. So like that, you'll get different, whenever you develop the project, you'll get different scopes. Different examples. Okay. Now, what is test scope? So these dependencies are used only for executing JUnit or executing unit test cases. Unit test cases. Unit test means here you can use JUnit, Mockito, okay, or TestNG. There are different testing libraries, but popular are JUnit, Mockito. Here also I'll say unit test code. So these dependencies are used only for executing unit tests and not during the compilation. Only for executing, only for compiling and executing unit test case, and not during the compilation of the main files, of the main source files, and running of the jar file, jar or var file. So test score means these dependencies are used only for compiling and executing unit tests, and not during the compilation of main source files and running of the jar or var file. That means, say for example, you see here. I will open this. If you see, here I put scope as a test for org Mockito, for org JUnit Jupyter. Okay, for all these three library dependencies. So I have put scope as a test. So what do you mean by scope as test means? These libraries, these dependencies will be used only during the testing while executing the unit test code of the project. And in addition to that, these are not used anywhere. That means even these are not used for compilation of these main files also. These are your business logic files, right? See, there are two sections, one source main Java and another source test Java, right? So just if I explain this. If you see, the dependencies that are specified the dependencies that are specified with scope test in pom.xml will be used only while compiling and running the unit test code. Where is your unit test code present? Here, right? In this section. These are all your unit test code. Okay. So while compiling the files present in this unit test code only, these dependencies will be used with scope test. And these dependencies will not be used in this section. This is your main section. So the dependencies with scope test are not used for the main source files. For the main source files, where your business logic actually presents. This is where your business logic lies. And also, so now what will happen now? All these files will be bundled to one jar, right? All these files will be bundled to one jar file. Now, and this jar file will be copied to the server. So all this jar file will be copied to the server. Now, while the jar file is copied to server and this jar file gets executed, even that time also these dependencies which are specified with scope test will not be running. Okay, it will not be used to running. Only these dependencies will be used to execute this unit test code only for unit test code. Okay. So that is what scope as test. Okay. Any doubts till now? Any questions? Okay. Now we'll see the another scope, system scope and import scope. Okay. These are a bit different actually. Okay. What do you mean by system scope? The dependencies with system scope with system scope are similar to provided. Scope with provided. What do you mean by provided? This one, right? The scope provided will be used for the dependencies that are only used to require building, that is compiling. So when I type fastly, right, sometimes I get these typing mistakes. So that's why I'm just checking, because I'll be typing fastly, right? So I get some dependency. See, some typing mistakes will get. So when I say provided, the scope provided will be used for the dependencies that are only required for compiling and testing the project. So here also the same. System scope also dependency system are similar to the scope with provided. But the difference is in scope provided, the dependencies are retrieved from local repository. And if not found, retrieved from remote repository. Right? So generally, all the dependencies, any dependency will be retrieved from local repository, not from remote repository. This is the flow we have seen. But for with the similar with the system scope, for the dependencies with system scope, for the dependency with system scope, dependencies with system scope, these are retrieved from a project subfolder, from the project subfolder path, and we specify the path. We specify the path whenever we mention the scope. Okay, for example, see, I'll specify like this. So dependency, say group ID. I have some library, org dot something like I'm say maps. Okay, I have a library for maps, group ID, next artifact ID. Okay, this is in maps library, and then version, I'll say 1.0, and here I'll say scope as system. And then here I'll say system path. and I give some system path like $#base_dir, say some slash, okay, lib slash, okay, I'll use some maps.jar. So this is the system path. And then I'll say dependence. I'll close the dependence. So this is how so whenever I say scope system means, so what will happen now? This maps jar will not be picked from either local repository or central Maven central repository. So it will pick the jar from this path actually. And this $base_dir is your project path. Wherever this project is running, so this $#base_dir is your project current path, the current folder path. Okay. So this base_dir is the project current path, current base path. Okay. So in the current base path, it will see the lib folder. In the lib folder, it will see this maps.jar and pick that jar and include this in this project. Include this in the class path of this project. The only difference is and this jar, so it's similar. And when I say it is similar to provided, what provided will do? Provided is used only for if you see provided, it is only required for compiling and testing the project, not during the running of the project. So this jar will be picked up from the system path location, from the given system path location, and will be used only during compilation So when I say compilation, build, okay, we can say build. Compilation and running of the project. Sorry, testing of the project. Because it is similar to scope provided, right? I told you it is similar to scope provided. It is similar to scope provided. Dependencies with system scope are similar to scope with provided, but only difference is the jar is picked up from this path, not from local Maven repository or Maven central repository. Understood, everyone? Clear? Any doubts? Okay. Anyway, I'll show you the practical. I'll show you the practical of this also. Okay. Let me complete the theory part and I will show you. Okay. Now, import scope. What do you mean by import scope? So before I explain this import scope, I'll give just an idea for you. See, always remember, always directly don't jump into the programming. First, understand the concept. If you understand the concept, even if you do programming like with some mistakes, also not an issue. You'll get, if you know the concept, you can fix the programming easily. Concepts are more important. Concepts are more important. Okay. So import scope. So before I explain this import scope, I'll just give some idea. Say, for example, let me take this. Let me take one library. Let me take some org dots or Spring Framework context Maven dependency. Okay, I'll just give it. So I'll go to this. This is your Maven central repository. I can select it. These are so many versions maintained on this. So I can select any version. So this is the dependency, right? Right. Now, this dependency is equal to some group of jars. So whenever I include this dependency in the project, so this dependency will resolve to some group of jars. Some group. Okay, there will be some set of jars present in this. Okay. We can see what jars also. If I import this in Maven project, see, for example, let me take this jar. Let me see. See, if I take this dependency, like that, any dependency. See, for example, if I put this Mockito jar, JUnit and Mockito jars, I can see what Maven dependency. I'll get some jars. See, these are the jars. See, if I include JUnit Jupyter API, these are the jars I get. JUnit Jupyter API.jar, API got some group of jars. Similarly, if I include Mockito core, I get some group of jars. Okay, I can show you that this dependency resolves to how many jars. This dependency resolves to how many jars. Similarly, I will include Spring dependency here. Okay, we can see how many jars will come. So I'll save this. Now you see, 1, 2, 3, 4, 5, 6. 6 jars have come. I mean, with this dependency, if I include this dependency, 6 jars are part of this. That means the developers who have written this library, who have written this dependency, who might have written this dependencies, the team from the Spring team. The Spring team who has developed this Spring framework has written this dependency, and they bundled some group of jars. If I include this jar, see how many? Spring context, Spring AOP. These are all jar files. Spring core, Spring JCL, Spring expression. All these are jars actually. So like that, similarly for JUnit also, we get some group of jars. Okay. And I'll show you that how to, in a Maven project, how to see which dependency is resolved into which jar and all that. Okay. Okay, fine. So this dependency contains some group of jars. And each jar, so that means one dependency, one Maven dependency. So one Maven dependency contains group of jars, like jar 1, jar 2, jar 3, jar 4. Okay, I'm just giving an example. Okay, like that it can be even 10 jars also. That depends upon the dependency library use. Okay, now each jar again contains multiple class files, right? What is a jar? That you might have studied in core Java or something, where a jar contains group of multiple class files are bundled in one jar. One jar can have three class files, 4 class files, 10 class files. I'm just putting a rough figure. So these are all class files. Java class files. Class files. Okay. And next, Java class files, libraries, property files, all. Okay. All this group of this. So each jar contains this. And if I import Spring Framework, all these class files are related to your Spring related classes. All the Spring related classes will be part of this. Okay. And these class files are written by you. You did not wrote these files, right? The Spring team has written the files and you are including that in your project. You are including that in your project. Okay. So like that, each jar contains multiple class files. Fine. Understood, right? And this Maven dependency, this is of type. So this dependency is dependency packaging type is jar. So this dependency packaging type is jar. So since this packaging type is jar, so this dependency includes all the jar files. Okay, multiple jar files. And each jar file contains multiple class files, multiple Java class files. So this dependency packaging type is jar. Okay. Now there is one more dependency type, which is called POM. There is one more Maven dependency type. Type called POM. Type, the packaging type is POM dependency. The packaging type. The packaging type is POM. Now, what the Maven packaging type POM will have is, now it will include various Maven packaging types as jar. That means whenever Maven dependency, the packaging is POM means it will have internally Maven dependency. The packaging type is jar. Here also the Maven dependency the packaging type is jar. Okay. Here also the Maven dependency Packaging type is jar. Here also the dependency. Packaging type is jar. Now again, this Maven dependency package type is now similar to this one. Now what I'm telling is this is one level above now. Now this one Maven packaging dependency type jar will contain multiple jar files, and inside jar file you'll have multiple class files. Now here this I'm now putting one level above now. Now what will happen now? This Maven dependency package type form time contains Maven package type jar, and now this contains multiple jar files. Okay, these are all jar files. So I know what will happen. So these are all jar files. Jar. This is jar. Okay. Similarly, we'll have like this. Now, sorry. Okay. Now this jar. This again contains jar. This is jar. Okay, this is jar, like that. Okay, let me put this only one there. Okay. Now this jar now contains multiple class files. Each jar. So each jar will contain multiple class files. So these are all class files. Java class files. Like that. That means when I take a single Maven dependency where the packaging type is jar, like this, this includes multiple jar files. Where, for example, if I include Spring dependency, I get Spring AOP, Beans, Core, JCL, Expression. All these are part of that. All these jars are part of single dependency. Now if I include Maven dependency packaging type as POM, when I include Maven dependency packaging type as POM, this contains multiple Maven dependencies of packaging type jar. Now again, each packaging type jar will have internally multiple jar. Now, whatever I'm showing here, this diagram is one level above this. Above this diagram. Okay. Now for a single Maven dependency, I get these many jars. Now I can combine these multiple dependencies into one POM actually. This is type POM. So this is what we call, the type is project object model. Okay. In other words, if I say you write a Java file, okay, you write 10 Java files. Okay. Now these 10 Java files, are compiled and converted to 10 class files. So these 10 class files are packaged into one jar. So it means, say you have some set of Java files. These are some set of Java files. And these are compiled. To class files. Okay. And these are bundled to one jar file. Similarly, you will have the similar set of Java files in another for another similar functionality. So these are also some set of Java files. So these are combined to dot class files. Okay. And these are packaged to one jar. Now these two jars are packaged to one Maven dependency, or bundled in one Maven dependency. Okay, I'm just giving. Okay, say you are developing a project where you want to share this to other people. Say, just like a Spring framework, you are developing a framework, and you want to share this to other to the entire world, or to the entire organizations or different organizations where they want to use your libraries, your Java files. Okay, so now this will be packaged to one dependency. Okay. Now similarly, you will be developing another Maven dependency related to the other functionality, but for the same purpose. Just like how Spring framework has different set of different dependencies. Okay, like that, your framework also will have different Maven dependencies. And how this Maven dependency has come? This Maven dependency has come from a different set of jar files. Now these two are combined. And they are bundled into one Maven form, actually. One Maven form. And this Maven form, where you will install is, you will install that in the Maven central repository. Okay, you will install this in the Maven central repository. Okay, now the other organizations who want to use your libraries, okay, these are the libraries developed by you. You developed a product, right, like a framework you developed. And the other organizations who want to use your library or framework, just like how we are using Spring framework, okay, or how we are using JUnit libraries, how we are using Mockito libraries, like that they want to use your libraries. Okay, now they will download this from Maven central repo and use it in their project. Okay, the other projects. So the other projects will download from the central repo. Okay. And use it in their project. So this is how the flow happens. Any doubts in this flow? Everyone clear? If you understand this flow, then I can tell tomorrow on this import scope. Okay. Okay. So you should understand this structure. Okay. Yes, both Maven dependencies create one form. Yes. I just told an example. It can be group of dependencies. In this example, I told 2 Maven dependencies. But there can be 10 Maven dependencies, 15 Maven dependencies, depending on that. But so group of Maven dependencies create one Maven form. Okay. So this is one way of representing. The another way of representing is from Java files, we convert to class files. Class files are grouped into one jar. So multiple jars are grouped into one Maven dependency. Multiple Maven dependencies are combined to Maven form. Okay, if you understand this structure, so tomorrow I'm going to explain you this import scope. So this import scope is related to this one only. Okay, I'll tell you that. But it is very important to understand this tree kind of structure. Okay, then. Any doubts? So tomorrow I'll continue. So I'll upload the notes today or tomorrow I'll upload the notes. See, DevSecOps and in fact, I'm telling you again, I told in the beginning of the class, this course is not related to pure DevOps or DevSecOps. These are the tools that we use in our development in DevOps and all that. This is the tools course only. But DevOps and DevSecOps is building the CI/CD pipelines. Okay. Next, environment like Kubernetes and all that. DevSecOps also will include the same section as DevOps, but in addition to that, security is also added. DevSecOps is DevOps plus security. So security is covered in DevSecOps. Okay. But this course is not DevOps or DevSecOps. So this course is the tools that we use in our daily project activities. So DevOps plus security is DevSecOps. So I'll cover the next topics I told you, right? So see, these are the tools that I'm going to cover. Okay, JUnit is covered already. Mockito is covered, and Maven is going on now. So Maven will be completed in this week. Then I'll cover SLF4J, which is logging library. Okay. After that, I'll cover SonarQube, Gradle, JMeter, Git, Jenkins, Jira, Docker, ELK, Datadog, CloudWatch, Heroku, Chef. These are the tools that are required. So JUnit and Market are already covered. So last 2 weeks we spent on these two. Okay then. All right then. See you tomorrow. Thank you all.